So same thing, I want to import the main simulation from the flip simulation, so this one. But this time I don't need to create source and use a pop solver, for example. I just want to create trails from the simulation. And in this case, it's actually easier to get the real-time version instead of the real-time. Just because if we want the real-time version, then I would have to use a solver with substeps, which make it a bit less easy. But let's see what is before first. Okay, so the main simulation. All right, I'm just taking the ground because I want to create the trail layer just over the ground and compute the distance attribute with the xyz dist function. Same thing, I'm blasting what is not close to the ground. All right, what is fast I don't want, so from the length of the velocity. In order to optimize, I don't want to accumulate all those points. They are very close and it doesn't make sense to mesh all of this. So let's fuse it and get something a bit more optimized. Same thing, if we are there, for example. Is it working? Yes, I guess, not sure. Yeah, okay. So I'm using a UV texture to optimize again from the camera view. There are a couple of ways to do that, and this is one way. So just computing the UV attribute from the camera one, and then here I'm just saying if the UV.x is inferior than 0, so it means if it's there, you know, or if the UV.y is inferior than 0, so it means if it's there under the camera. The superior than 1 is the right part, and superior than 1 for the y UV, it's upper there. And an important thing to do is if the UV.z is equal to 0, then it's back to the camera. So with those conditions, I'm just removing all the points that I don't need. And this is what I get. And I didn't specify that the threshold is a kind of how much I want to remove it from the camera. So for example, if my camera is moving quite a lot, then maybe I should increase a bit this number to make sure that I have all my my points. But yeah, let's set back to the original value, which was 0.1, and continue. Same thing, deleting everything that I don't need, which means all the attributes, and creating a solver to add each new point to the previous frame, to the previous points as well. And that's it, just a merge. So this is what we get. Yeah, just accumulating all those points. But at the end, it makes quite a lot of points, especially for my laptop. So again, I decide to fuse it to optimize again. So now it's 11,000, and before it was 26,000. And this is what we get. Yeah, the kind of trail we want. I thought it was more realistic that way, but I don't like those very straight lines, and this is why here I'm adding a bit of noise. Sorry, a bit of noise, just adding a turbulence noise, but I don't want to set it on the y-axis. That's why here I set the component to 0 if I don't plug anything there, and that's it. Same thing, I would like to clamp the position and use the same process with the p-scale, the VDB from particles, VDB reshape and reshape to get finally this one. All right, and let's see directly the flipbook. So we see it is the step 9 for the particles. So yeah, this is the trail layer. As you can see there, it's not very accurate, actually not at all. But you could increase the number or the substeps or whatever you want. But actually I don't think it's very visible. But you could, that's for sure. Let's see the mesh version, 10. Yeah, like this. Yeah, see, it's not, you don't really notice it. Just a bit, but that's okay. Good. Let's continue. So that was the third layer, the third extra layer. So let's go with the droplet setup.